Hello friends, welcome to our channel Knowledge Amplifier, and today in this particular video I am going to discuss understanding different ways to invoke Lambda function and how you can add destination in Lambda function, that is that particular destination will be executed on successful execution of our original Lambda function, or that destination will be executed on failure of our Lambda function, like those kind of things, how you can configure that I am going to discuss. Okay, but before going ahead with that destination discussion, we should understand the invoke type, because one particular terminology I am going to use while discussing that topic. So I just want to make you clear idea that what are the type of invocations possible, right? So generally there are two types of invocation. One is synchronous, another one is asynchronous. Okay, so what is synchronous invocation? That is, if the requesting object executes a synchronous action, that time it will be blocked until a reply is received from the requested object. Okay, that is, suppose client is there and that client is requesting our Lambda to do something, then it will be blocked. That client will be blocked until the client gets some response from the Lambda function, that is the requested object. Once they get back the response, then only it will go ahead with other words. For that time being, when the request is getting executed by the Lambda, that time the client will be getting blocked. Okay, he or she should not do some other work. Okay, even if no return value is required for this kind of invocation, the requested object must send back a message indicating the processing is complete. Otherwise, the client will be keep on waiting, right? And the requesting object is allowed to proceed with its jobs only if the response it will get back from the requested object, right? I hope up to this it is clear to you. And for functions with long timeout, maybe suppose you have created one pipeline where you're requesting something to Lambda and Lambda is taking long time, that time you should wait that much time, right? So your client who is basically making request, that might be disconnected during synchronous invocation due to this long timeout while it waits for a response. Okay, that is, client has made a request and the request is taking long time to be executed, and by that time it might happen that your client will be disconnected. Okay, so you have to configure your HTTP client or SDK, firewall, proxy or OS, whatever, to allow for long connection with timeout or keep alive setting. Okay, that is, you should make sure that your client is not getting disconnected while keep on waiting for the response for long timeout events. Okay, so in simple words, we can summarize this whole synchronous invocation in this particular picture. That is, client will put an event request to the Lambda will process that request and will send back the response, then only client will go ahead to do some other work, right? Simple picture is clearly explaining the whole concept of synchronous invocation, right? Now let's see one example. Like if you consider this particular pipeline where we are having some API, okay, maybe that is related to sales. Okay, we want to know how much total amount of orders was given for a particular product. That time we will make a get request, okay, right, with /order. This is our basically resource path. It will be going to Lambda. Maybe that Lambda is connected to RDS, DynamoDB, whatever, and from there it will read the data and it will send back to the front end, that using a HTTP API or REST API, right? So the thing is, when we are making some get request, that time we are expecting some result to be returned. Okay, that is, this kind of pipeline it is happening. So we will not proceed just by making the request. We need the response also, right? So this is kind of synchronous invoke. Okay, right? So now let us go to what is asynchronous invoke. Okay, so in asynchronous, what happens? There is synchronous. We understood that client will wait until it gets some response back from the requested object, right? So asynchronous is just reverse. That is, it will not wait, right? That is, the action returns no value and the requesting object does not wait for a reply from the requested object. That is, client will make a request to be processed from Lambda, and then once it is fired, he or she will forget that. Okay, right? It will not wait for that particular response or some kind of return value, right? So that is called asynchronous invocation. Now let me explain you how this particular asynchronous invocation works with Lambda. Okay, so suppose the client is SNS. Okay, SNS is making a request, and you just consider this particular box as Lambda service. Okay, inside that Lambda service there can be multiple component. One component is our actual Lambda function. Okay, so this is our inside Lambda. Okay, now SNS is making one request, right? And then what will happen? Here our Lambda function is sitting. It is not like the request will directly go to the Lambda function. What will happen? There is an internal queue. Okay, I hope you have already studied queue in your data structure and algorithm course in your BTech degree, right? So the request, whatever the SNS is making, that will be coming to internal queue. Okay, and as soon as the request will come to the internal queue using this particular gateway, that time what will happen? It will send a success response. Okay, that is Lambda function is not yet executed. Only the message, the request is now appeared in this queue, and then this particular Lambda service will send a success response that okay, that particular request is now in queue. Now our actual Lambda function will process that, but the particular request is now successfully got submitted to the queue. That success response it is sending. Okay, it is not the success of the successful execution of Lambda function. Okay, just successfully it is loaded in the queue. That's what it is returning. Okay, right? The Lambda might fail in later point of time, but this success is indicating the request is now appeared in the queue. Okay, now there is a completely separate process, this particular side in the right hand side. Okay, what this Lambda function will do, it will read that request from the queue. Okay, and then it will process. Okay, so the thing is, now this particular Lambda function no need to return something to the SNS. Okay, all it is doing, the SNS is firing some request and it is forgetting. It started working on something else. The client started working on something else. He or she is not waiting to get back the response from the Lambda, and this is how the mechanism is working. Okay, right? And there can be some possible situations of failure also. So what AWS documentation is telling us on the failure cases, that is, once a message is injected into Lambda's internal queue, it will try to process those messages. Okay, that is, our Lambda will try to process those messages. Okay, if the Lambda execution fails, that is, suppose here in this particular queue our request is present. Now Lambda is trying to read that request and process that, and that time it is failing due to any random exception, then the message will be returned back in the internal queue 3 times. Okay, that is what will happen. Now if the message is in queue, first time the Lambda will try to read, suppose due to some reason it got failed, it will write back in internal queue. Again it will try to read, again if it fails it will write back in internal queue. Like this way it will try to do this kind of thing 3 times with some degree of temporal backoff or cool off period between each attempt. That is, it will not happen that all the as soon as the particular execution will fail, it will write and then and there it will read again. It is not like that. It will make certain gap of time or certain interval. With some interval it will be trying or re-attempting, okay, to solve that particular request. Okay, so that's what it is written here, that it will try to process that 3 times if failure happens with some degree of temporal backup or cool off period. Okay, that time, suppose 1 minute or 2 minutes, with each 1 minute interval, if it fails, if the execution get failed, then after 1 minute it will try again. Like that you kind of thing you can configure here, okay, in this setting. Okay, and suppose 3 times, after 3 times attempt also it got failed, that time what will happen? That is, after 3 failure, it's game over. Okay, Lambda will not do any attempt more. Okay, for that particular message, it will now go ahead with other messages. Okay, and the Lambda will abandon this particular request and send it to your DL queue or dead letter queue. Okay, that is, suppose for example 3 times attempt it did, and till some random exception is appearing, then Lambda will go ahead with some other request. Okay, what it will do before going ahead with other request, that particular request it will put in DL queue or dead letter queue. Maybe from here what you can do, you can create one SNS topic to send email notification, email alert to the developer team, to the admin team to look into it. Like that kind of things you can add here, right? That kind of programming things you can add But overall, this is how this kind of asynchronous invocation works. Okay, that is, SNS is not waiting to get back the final response from the Lambda. Okay, it just fired and forget the response. It started working on something else. Okay, that's what it is written here. There is an action returns no value, and the requesting object, that is in this particular scenario the SNS, does not wait for a reply from the requested object, that is this particular Lambda. It will not expect some response. SNS will go ahead with some other word, right? So these are the two things. One is synchronous invocation, one is asynchronous invocation. In asynchronous invocation, our main mechanism is controlled by this internal queue. Okay, this queue is basically taking the response, and then our actual Lambda function is basically taking that particular request from that particular queue and started processing. Okay, and this whole thing is happening in the backend. Okay, this is inside Lambda. This whole box is our Lambda service. Inside that, in the backend, it is happening. The user no need to think that how this is getting processed, how it is getting handled, all this. Okay, user only need to know how he or she can trigger SNS with Lambda, like those kind of settings how to do, and the programming part. These all things will be taken care of by AWS Lambda service in the backend. Okay, that internal queue and separate process execution for Lambda function and all this. Right now, let's directly jump in how we can configure the Lambda destination. Okay, so what is Lambda destination? If you go to this particular Lambda, okay, right, and let me first create one function. Okay, maybe I can give demo destination YT. Okay, the language I'll be choosing Python 3.9, right, and the install properties I am keeping same, and then here I am creating the function. Okay, right, it will take some time to create this particular Python function. You can choose some other runtime execution environment based on your requirement. So see here, already we worked with add trigger multiple times. There is sometime we trigger with S3, sometime we trigger with AWS API gateway, sometime SNS, blah blah, many things are there. And if you see in this right hand side of this particular Lambda function, you will see destination. So I am going to talk about this particular one. Okay, so what it is written, let us first try to understand some theory. That is, with destination you can route asynchronous function results as an execution record to a destination resource without writing additional code. Okay, that is, suppose your Lambda is getting success or getting failed, that time you want to make some asynchronous invoke to some other AWS service. That kind of thing you can do with destination. Okay, and when you add destination, what are the things this particular actual Lambda function will send as part of invoke? That is an execution record it will send, and that will contain all the detail, that is request and the response in the JSON format, including version, timestamp, request context, request payload, response context, response payload, all these things. Okay, that is, if you add some destination, then suppose the Lambda is getting succeeded or failed, based on that, suppose you configure to trigger some destination asynchronously, that time that particular other AWS service will receive the request JSON and the response JSON, both things. Okay, that is, request JSON is nothing but due to which purpose this Lambda got triggered, that is contained in the request part. Okay, and response is nothing but what is the response the Lambda is generating after processing of that request. Okay, that is, both the things it will send to the destination. Okay, that's what here it is written. For each execution status, for success or failure, you can choose one of the four destinations, either another Lambda or one SNS or one SQS or an event bridge. Okay, only these four destination combination possible, where you can asynchronously invoke these kind of services. Okay, so the picture kind of looks like this. There is in Lambda function that can be triggered using all these kind of possible options, and then you can configure that is on success, suppose one particular Lambda, another Lambda should be triggered. Okay, on failure, some other SQS, SNS or event bridge should be triggered. Only you are having these four options, and this all will be happening asynchronously, not synchronously. That means when the Lambda will trigger other among these four, then it will not wait to get back some response from these services. Okay, once it will fire the request, it will forget that. Okay, Lambda will be done. It need not wait. Okay. And for this kind of triggering functionality in the destination, you no need to add any additional code for this kind of things. Okay. I'll be showing you all these things, right? So without any further delay, let's directly jump into the practical session. So here we are having one Lambda code. Let me replace that with some other code. So here what I am doing, I am replacing that with this. Okay. So what is done here? If you see this code, very simple. We are importing JSON and Boto3, and this is our def Lambda handler. Our actual Lambda function, which will be called as soon as Lambda will be triggered, and event and context as we pass generally. Then basically this particular Lambda function will trigger based on S3 object creation. Okay, we'll be creating one particular S3 bucket and we'll be configuring the trigger. Okay, we are extracting the bucket name and file name. We are printing the event. Now, if that file due to which this particular event is getting triggered, if there is versicolor.csv or virginica.csv, then it will print the success. That means Lambda will be successful. Else, if it is triggering due to some other file, we are doing 0 by 0. That is, 0 division error will be appearing, right? And that time we want to trigger some other destination. That's what I am going to show. That is, for successful execution, some destination will be triggered. For failure execution, some other destination will be triggered, so that both cases will be covered and you will be comfortable in both cases, right? So here I have deployed this particular code successfully. Now here let me add the trigger. I will go to S3 and then here I will be creating one bucket. Okay, right, for this particular demo, right? So here I will create a bucket demo testing data version. Okay, and then list all properties I am keeping unchanged. Block all public access. Okay, right, and bucket versioning also. Okay, I am going to create this bucket. So here my bucket is created, right, and I will make this trigger. Add trigger. I will search for S3, and here bucket name is this particular one. I will choose that. And then event type, suppose when object will be created, then only we want to trigger the Lambda. So all object create event I am keeping, and then recursive invocation I don't want, so I will check this one, and then here I will click on add. Okay, so our trigger is getting added. Okay, now we need to configure the destination. Okay, so what we can do, maybe for successful execution we can trigger some other Lambda. Okay, and for failure execution of this particular Lambda, we will send email. Okay, right, so both things let me configure. So I will go to AWS management console and I will go to Lambda, and then here I will be creating another Lambda function which will be executed on successful execution of our first Lambda, and name I am giving second Lambda YT demo, right? And then here Python environment I am choosing, and then here I will create the function. Okay, right? So here it is created. All we can do for this particular one, we can print the event. Okay, we want to see what kind of event has triggered this particular Lambda. So it will be printed in the CloudWatch. That's it. Okay, now we will add this one in the destination of first Lambda. We'll go to add destination. See, asynchronous invocation. Now you know the meaning of asynchronous. That's why I have discussed first what is the meaning of synchronous and asynchronous, right? Now asynchronous invocation we want to make on successful execution. Destination will be Lambda function, and then here I am choosing second Lambda demo. As soon as I choose that, it will be taking the ARN, Amazon resource name, and here it is giving your function's execution role does not have this permission to send the result to the destination. By clicking save, you will add the permission. Okay, fine. So I will add that, and here I will click on save. That's it. Okay. So basically, when our first Lambda function will be successfully executed, that time it will automatically trigger the second Lambda also asynchronously. Okay. So this is created. Now maybe I will add one more destination when this particular first Lambda will fail. Okay. So I will go back to my AWS management console. I will go to simple notification service, and here I will be creating a topic demo YT. Okay, AWS Lambda. Some name I am giving. Then here I am clicking on next step. I want to create standard topic, right? And then here Encryption I am keeping default. Access point, everyone can publish, everyone can read, or everyone can subscribe. With that note, we can create the topic. And here our topic is successfully created. I need to create one subscription. So when our first Lambda will be failing, that time we want to send email. Okay. So here I will paste the email address. So here I have pasted the email address to be sent notification once our original Lambda will be failed. And here I will click on create subscription. Now it is created. Now if I go back to topic, you will see here pending confirmation. So we need to go to our actual mail and maybe refresh this particular one. See here one mail came. We need to confirm the subscription, right? And here our subscription is confirmed and we are all set, right? And all we need to do, we need to go back to our first Lambda function. We will add a destination, and once it is failure, okay, once our first Lambda will fail, that time we want to trigger SNS. Okay, destination will be which one? Destination will be this particular one. Okay, that is demo YT AWS Lambda. So if I go here, this is the one. So I can choose and I can click on save. Okay. So basically the setting is this second Lambda will be executed or triggered on success of our first Lambda, and this SNS will be triggered on failure of our first Lambda, right? We are all set. Now let's test it out. So all we need to do, we need to upload first versicolor.csv file. So it will success, it will just print the success, that is first Lambda will be successful. Okay. Then what should happen? This particular second Lambda should be triggered, and in the CloudWatch logs we should see what is the event which triggered this particular second Lambda. That is, that particular event should contain all the detailed information, that is the request as well as response. Okay. Maybe let me return something after printing. Right. So we want to see in the second Lambda both the request and response of the first Lambda is going, right? So we have deployed successfully. Let us go to S3. Let us go to our bucket, and here I will click on upload, and here I will click on add files, and then here first upload versicolor.csv, right? Here we will click on upload. This uploaded successfully. So what should happen? This particular one should asynchronously invoke this first Lambda. Let us see. We will go to monitor section, and then here we will click on view logs in CloudWatch. This is for the first Lambda we are checking. Okay. So here we are getting one logs. Click on that, and here it is printing success. Okay. So this is basically the request or event due to which our first Lambda got triggered. Okay, right? So what is the expectation? The expectation is basically the second Lambda also has to be triggered. So let us go to our second Lambda, this one, and let us go to monitor section, and we will click on view logs in CloudWatch for the second Lambda. Okay. And here we are getting one log just now. Okay. So if I click on that, here you will see that it is successful, and here this particular event what we are printing, it contains all the information, that is the Lambda version, the timestamp. See here request context. What is request context? For the first Lambda, what is the request? That's what it is giving here. If you see here properly, you will see request payload. Okay. That is event source is AWS S3, AWS region. Event time is also it is printing. Event name is object create put event. That is in our first Lambda it got triggered due to some object is created in our S3, right? Okay. Up to this, I hope it is clear to you, right? And then here you can see the bucket name, demo testing, data, Farsi. That is the bucket where actually it got loaded, right? And then here see our file also versicolor.csv. All this request, that is due to which our first Lambda got triggered, all these things it is printing. And then response also, it is response context, status code 200, that is successful, and response payload, that is our first Lambda, whatever returning, that is stored in response payload. See what it is giving from first Lambda. Okay, that is in this particular first Lambda. If I show you the code, here you will see that we are returning from first Lambda, right? So basically all the information, why our first Lambda got triggered, in request payload we are getting, what is our first Lambda returning, that response payload we are getting in the destination Lambda, which is basically executed on successful execution of first Lambda, right? I hope it is clear to you. Now let's see how it will handle the failure event. So AWS SNS it should trigger on failure execution, right? So all we'll do, we'll go to S3, we'll go to this particular one, we'll click on upload, we'll add files, and here we'll upload some other file apart from Varsinica or Vargicolor. So maybe Setosa I will upload. I'll click on OK, and here I will upload that. Okay. So according to code, what should happen? If you see the code, if the file name is Varsicolor or Varginica, then only it should print success. Else we are doing 0 by 0. That means the Lambda will fail, right? As soon as it will fail, one mail we should receive. If I go back to inbox, okay, if I refresh this particular one, maybe let me go to mode, let me go to all mails. Okay, it is not yet triggered. Let me see the CloudWatch logs. So if I refresh this particular one, here see, error is created perfectly. Zero division error, that is division by 0 is not possible, right? So this particular one should trigger this SNS, right? This asynchronous invocation, that is this one. And this, if we go to this particular SNS, is still showing pending confirmation. Why? We refresh this particular page. Okay, this status is confirmed. So in this particular mail, we should receive some mail. Maybe it might happen sometime, that is when you are creating this kind of configuration, the Lambda, the AWS will take some time to update all these policies. It might happen. Okay, so we might need to wait and retry once. Okay, so for the first time if you are doing, that time this kind of thing might happen. Okay, so let me upload one more file which will, apart from Varsinica or Varsicolor. So it is done. Let us wait for some time. Then I'll try it again. Maybe it is not yet configured in the backend. See, in the inbox already mail came, right? So this is perfectly working. Just we have to wait little bit in for the first time. See here what it is telling, version 1, okay, timestamp, okay, right? And here all these details you are getting. That is response payload, error message, division by 0, okay? That is 0 division error, right? Because that's how we wrote the code. Maybe let me show you one more time. I'll close this particular one and I will click on upload. I'll add the files. Let me show you another case, maybe big table testing I will use. I'll open that. So again we should get one more mail. Okay, it's uploaded successfully. If I go back to AWS Management Console, if I refresh this particular page, so if I go back to CloudWatch, just now we also got zero division error, right? So now it is basically it has triggered is added Amazon SNS. Now it will take some time to process that. Also check the spam mail also, if some by mistake if it is going to spam mail or not. And see here, mailbox, new mail came. See here just now, and again it is telling that zero division error, and due to which file it got triggered, our actual lambda got triggered, that also you'll be getting from here. If you search for it, see transfer credentials fathers.txt. Okay, we uploaded something like that, so right earlier in history. We uploaded this one, right? So big table testing also, one mail will come soon. So this is the way basically how you can configure this particular destination, and this is happening asynchronously. So I hope the broad picture is clear to you. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you.